Today, I'll be briefly discussing population dynamics in ecology. So this will be focused on characteristics of populations and also factors that can affect populations. All right, start off with population density. So population density is talking about how many individuals per square unit. Okay, so I'm going to write that down. Actually, we can call that number of individuals in one area or per area. So you can see over here, the map over here is the population density, human population density in the United States. And this is kind of a more three-dimensional map. The areas with the spikes are where we have higher population density. So you can see kind of all along the East Coast, there's a little bit higher population density than there is in the Midwest. This looks like New York, metropolitan areas, New York, DC is down here, Florida, and then over here you have like Los Angeles, San Diego type areas. All right, some factors that affect populations are number one, immigration and emigration. So immigration and emigration, we're talking about immigration is when individuals come into a population. So into starts with an I, immigration starts with an I. So that's how you can remember it. Emigration starts with an E. So this is where individuals exit the population. So if individuals are exiting the population, it's going to have, the population will decrease. When individuals are entering the population will increase. All right, a limiting factor. So these are the things we're going to focus on in ecology. These are biotic or abiotic factors that could cause a decrease in the population size. So anything that can limit the existence of an organism. These are going to be things like resources, living space, and resources could be water, food, mates, okay, living space, and then we're going to get into actually some more abiotic ones as well. But anything that can limit the existence of an organism is a limiting factor. If you don't have enough food, your population will not continue to grow. You don't have enough space, no room to go to. All right, some density dependent and density independent limiting factors. So density dependent, let me change my color, means that it relies on or exponentially affects the higher population density. So these are biotic, meaning they're living factors. Okay, they have an increasing effect with larger populations. So these are things like competition, right? You have more organisms in one small area, then you're going to have more competition because they're going to be competing over those limiting resources. All right, predation, right? If there's more bunnies around, then the wolves are going to be able to find them easier because there's just less space to go. All right. Disease. A disease can spread if there's higher population density. So think about some of the areas that were hit hardest with the coronavirus. Those would be our metropolitan areas or the areas that had higher population density. All right, density independent factors are abiotic factors that will affect the population regardless of size. So it affects population regardless of size. So these are things like natural disasters, drought, tornadoes, hurricanes. I spelled that wrong. Those are going to hit an area regardless of how dense the population is. So those are abiotic, these are biotic. All right, important to remember. All right, now population graphs. This is a typical population graph that organisms follow in an area. So if you should remember, population is a group of one species of organisms. So they always start out kind of slow. All right, and then it'll, once they're kind of an established population, it'll begin to grow exponentially. So really rapidly. Okay, and then it will begin to level off here once some of the resources have been used and there's a lot of individuals in the area. So this leveling off we call the carrying capacity. Its symbol on a graph is called K. So this is the maximum amount of individuals that an environment can support. Okay, so this is like the proposed graph, this nice straight line, and then this jaggedy line is kind of what happens in real life or with real organisms. So usually the organisms will overshoot, meaning that they will actually have more individuals that can be supported in the area. And then that's why you have this drastic decline, because they'll die off and then they'll kind of float around this carrying capacity. All right. Sometimes producing too many, sometimes too little, so then they'll grow some more. But the environment cannot support any more than what's already in the carrying capacity.